how to create a credit card payoff spreadsheet in Excel. So let's roll up our sleeves and get started. For this tutorial, I'll be using Microsoft Excel 365. Before creating the payoff spreadsheet, we must know what credit card payoff is. When you use a credit card to buy things or get cash, you are basically borrowing money from the company that gave you the card. This borrowed money adds up as a debt on your credit card. The credit card company usually makes you pay extra money, called interest, on this debt until you have paid it all back. To pay off your credit card, you have to keep giving the credit card company money regularly. This money helps you pay off the debt until it's fully repaid. In this method, I'll use the NPER function to calculate the number of payments to pay off the debt. Then, I'll apply the sequence function to auto-populate the number of months in the dataset. Finally, I'll implement some generic formulas to create a credit card payoff spreadsheet in Excel. Firstly, type the column headings. I'll insert 4 different columns. First, in cell B4, I'll write month. In the next column, payment. Then interest. Lastly, balance. Let's format them. Select cells in the B4 to E4 range. Press Ctrl+B to make them bold. Click on middle align and center align icons to align them perfectly. Increase the font size to 12. Apply a fill color to them. I'm applying orange accent to lighter 80%. Also, I'm applying all borders to the range. Secondly, type the headings for debt information. In cell G4, I'll write product price. Our assumption is that we are using the total debt to buy a product. So this amount equals to the total debt. Let's take it 1699 USD. Yearly interest rate. Annual interest rate set by industry standards. I'm inserting it as 19%. Monthly payment. The amount of payment we'll make per month. Assume I want to pay a monthly amount of $100. Number of payments. We'll find this value using the NPER function. Now select cell B4, then go to the Home tab. In the Clipboard section, click on Format Painter option. It copies the formatting of the selected cell. Now take the icon to cell G4 and apply the copied formatting to G4 to G7 range. And I'll apply all borders to the H4 to H7 range also. In cell H7, insert the formula to determine the number of months. Place an equal sign. Here I'll use the NPER function. Press Tab to select the function. As the rate argument, I'll insert H5 divided by 12, as the PMT argument, I'll insert minus H6, as the PV argument, I'll insert H4. Close the parenthesis. Firstly, I have divided the interest rate by 12 to find the monthly interest rate from the yearly interest rate. Then, I put a negative sign with the monthly payment amount in cell H6 to indicate it as a negative cash flow. Lastly, I use the product price as the present value. Press Enter. Afterward, type another formula in cell B5 equal to, here I'll use the sequence function. Press Tab. As the rows argument, I'll use another function round. As the number argument of the round function, I'll select cell H7, as num digit argument, I'll insert 0. Close the parenthesis, again closing the parenthesis. Press Enter, and this formula will autofill the number of months by incrementing by 1. Here I use the round function to round the number of payments value. By payment in column C, I'm referring to the previously specified monthly payment value. In cell C5, use the formula equal to cell H6. Here I'll use the absolute reference. Press Enter. Select cell C5 and bring the cursor to the right bottom corner of the cell. It is the fill handle tool. Now double click on it to copy the formula to the rest of the cells. Next, I'll find the initial balance by typing formula in cell E5 equal to H4 minus C5. Press Enter. To find the interest amount accrued for each month, I'll use a formula in cell D5 equal to E5 into H5. Here I'll use the absolute referencing divided by 12. I'm dividing the yearly interest rate by 12 to use the monthly interest rate value. Moreover, if you need to calculate the daily interest rate, then you will need to divide it by 365. Press enter and use the fill handle. After that, let's add the interest amount to find the balance for the rest of the cells. In cell E6, type equal to E5 plus D5 minus C6. Here I am adding previous month's balance with that month's interest and subtracting current month's payment from the amount. That's how I have got the present balance. Also, here I will use the fill handle to copy the formula to the rest of the cells. As the data is long enough, I will collapse the ribbon to show it in the display. Right click on the ribbon, select collapse the ribbon. Now we can see the whole dataset. Here I'll apply all borders to the data range. Again, I'll bring the ribbon back on. To do this, click on any tab on the ribbon. Again, select collapse the ribbon option. And that's it. Now, if you change any of the values, the spreadsheet will change accordingly. Let's change the monthly payment amount in cell H6 to $200. Press enter. You can see that there are extra rows from my previous steps. But why is this happening? You saw that I increased the payment amount from $100 to $200. When you increase your payment amount beyond the minimum required, you start to pay down the principal balance more quickly. This reduces the amount on which interest is calculated. So the total debt can be paid in a lesser number of months. Now, I'll use a simple VBA code to hide the rows that have empty values in column B. To do so, right-click on the sheet name and select View Code from the context menu. It will open the Microsoft Visual Basic for Applications window, and you can see a code module inserted for this particular sheet. The code you enter here will be applicable for that sheet only. Now, I'll paste my VBA code into the module. We'll find the code from the article link in the description box. To begin with, I'm using a private sub-procedure as I won't call this outside of this module. Then, I declared the variable type. After that, it will go through the cell range B7 to B100 using a for each next loop. Here, the first range value is set to B7 as I want to keep the rows up to this intact. Next, if any cell value within that range is blank, then the code will set the entire row.hidden property to true. Consequently, this will hide the rows, else the rows will be visible. You don't need to run this code. This code will work automatically upon changing the parameters of the credit card. Let's close the VB editor. Now, if I change the value to $150 and press enter, look, the dataset is changed and the extra rows got hidden. Again, if I change it to 200, again the number of rows get lessened. So, we can understand that if we change any values, the code will be executed and it will hide the rows. In this method, I'll incorporate a downloadable template from Microsoft to create a credit card payoff spreadsheet in Excel. Go to the File tab, select the New option in the left side panel. In the search box, type credit card and press enter. Alternatively, press Alt F-N then S to activate the search feature for creating a new workbook based on a template. And enter. Here, select credit card payoff calculator from the search result. Afterward, click on create. It will create a credit card payoff spreadsheet. Now, I can input different values and it will show the number of months required to pay off the debt and the total amount of interest. Let's minimize the ribbon. Here you can insert the balance, the interest rate, the minimum monthly payment, and the proposed monthly payment, and the corresponding results will be shown here. Also, you can see the comparison of minimum payment and proposed payment in terms of months to pay off and total interest in two different graphs. In this tutorial, I have shown two methods to create a credit card payoff spreadsheet in Excel. Use the one which comes in handy for you.